Okay, so we're going to go ahead and do 9-6 part 2. And really in this lesson is longer. We're going to be delving deep into the quadratic formula. We're going to do some more quadratic formula problems. I'm going to show you guys another method for it, or kind of, another answer type for it, some word problems, and then we're going to talk about the discriminant, which is really cool, and that'll be in the last video. So this is just all about the quadratic formula. Now, remember in the last video, we derived the quadratic formula by completing the square. So, using logic, if completing the square is a method that will always work, and the quadratic formula comes from that, the quadratic formula too will always work. Okay? It works for anything and everything. And then actually not tomorrow's lesson, but the following lesson, we're going to be talking about which method would be best for different situations. Okay? All right. So, let's remind ourselves of what the quadratic formula is. It is, hopefully you enjoyed my TikTok and you're able to memorize it. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now remember, this is only true if we have a quadratic in standard form so that we can identify the a, b, and c correctly. So in standard form, a quadratic looks like a x squared plus bx plus c equals 0. Okay? So in our first example, we have 5x squared plus 16x equals 84. Now, the problem with this is a quadratic, it's nice, but it's not in standard form. So if we want to use the quadratic formula, we have to put it in standard form. We have to make it equal to 0. So we do that by subtracting 84 from both sides of the equation. When we do that, we're going to notice that 5x squared plus 16x, those can't combine with 84. They're not like terms. So we just write it as 5x squared plus 16x minus 84 is equal to 0. Now we have a quadratic in standard form, and we can identify our a as 5, our b as 16, and our c as negative 84. Okay? From there, we use the quadratic formula to substitute our values in. Now, if you feel like, okay, yep, I can totally do this, go ahead and try this on your own. If you don't, you can go ahead and watch. All right, let's see how we did. So we're substituting our values in. X equals negative b, and b is 16, plus or minus the square root of b squared, that's 16 squared, minus 4 times a, which is 5, times c, which is negative 84. And that's all divided by 2a, which is 5. Okay, when we evaluate this, the first thing that we're going to do, according to order of operations, is the grouping. So everything inside of the radical. So I'm going to just write what I already know, negative 16 plus or minus, and now I need to figure out what's going on inside that parenthesis. So I have 16 squared, and that's going to be 256, minus 4 times 5 times 84, or times negative 84, which is going to be negative 1,680. Okay, and that's all still divided by 2 times 5. We could evaluate that to 10. Okay, let's do a little more simplifying. We can do inside of the radical right now, we have minus a negative. Change that to adding a positive. So it's 1680 plus 256. Okay, then we're going to get negative 16 plus or minus the square root of 1936 divided by 10. Our next step would be to take the square root of 1936, and we're going to find that that's exactly 44. So we will have x equals negative 16 plus or minus 44 over 10. Okay, now from here, we have this as simplified really as we can get it, and we can now break this up. Since we have a plus or a minus, oopsies, plus or minus, that means two things can happen. We can have negative 16 plus 44 divided by 10, or negative 16 minus 44 divided by 10. And those are the two possible solutions we can get. Okay, negative 16 plus 44, that's the same as 44 minus 16, which would be 28 over 10. Okay, so 28 over 10 is a possible answer. We can simplify that a little bit. If we divide both sides by 2, it looks like we would, or sorry, the top and the bottom, numerator and denominator by 2, and we would get 14 over 5. So 14 fifths. If you prefer decimal, that would have been 2.8. Okay, so x can be 14 fifths or 2.8. With the other equation, negative 16 minus 44, that's saying like negative 16 plus a negative 44, which would be negative 60 divided by 10, and that divides to just get us negative 6. So the two possible answers are that x can equal 14 fifths or x can equal negative 6. Okay, now that's just a review from last time. We have some fractions here, so maybe a little bit different, but not too much. On this next example, we are going to look at a different way of writing our answers, okay? So we have example 2 is 2x squared minus 16x equals negative 25. At this point, we should be pretty comfortable in seeing this isn't in standard form. To make it in standard form, we do need to add 25 to both sides of the equation. When we do that, we'll get 2x squared minus 16x plus 25 is equal to 0. Now we can identify our A is 2, our B is negative 16, and our C is 25. We're going to substitute those values into the quadratic formula. So we'll have x equals negative 16 plus or minus the square root of b squared, so that's negative 16 squared, minus 4 times a is 2 times c is 25, and it's going to be all over 2a, or 2 times 2. Okay, we're gonna do the same thing next. We want to use order of operations to first simplify what we have in our grouping. So I'm gonna write down what I have so far so I don't forget it. First, I have a negative 16. Okay, I can use some logic. I know a negative 16 is just a positive 16. Plus or minus. Now negative 16 squared, it's the same as 16 squared, which we did up here, which was 256. So that's 256 minus, and now I have 4 times 2 times 25. Okay, well, I do know 4 times 25 is 100, so times 2 would be 200. Oh, why? Oh, my. Okay, there we go. Now on the bottom, I have 2 times 2, which again, I can evaluate that to 4. All right, now I have 16 plus or minus, I can do 256 minus 200 is just going to be 56. All over 4. Okay, now this is where we get something different. So typically what we've been doing is, okay, now we have this square root. We're going to use the square root symbol, type in 56, and we're trying to find the square root of 56. What happens now is we get an irrational number. That is an irrational number because 56 isn't a perfect square. This isn't going to be something that we can perfectly just add and subtract. Now we have to deal with rounding and all of that stuff. So here's what we're going to do. I'm going to show you how to get an exact answer and how to get an approximate answer, okay? So for the exact answer, we want to simplify that square root of 56. So if we think back to the exponents unit, all the way back in January, that was statistics, maybe February, we had a radical like this, and we would want to simplify it by finding, is there a perfect square in 56? Okay, so you can kind of think about it. Does 4 go into 56? Does 9 go into 56? And so on. Do any of our perfect squares go into 56? Well, 4 actually does 14 times. So I could rewrite this radical as, whoopsies, the square root of 4 times the square root of 14. Well, I know the square root of 4 is 2, so this would be 2 rad 14. Now, to make sure this is completely simplified, I want to see, are there any perfect squares in 14? Well, 14 is just 2 and 7, so there's nothing else I can do. So the simplified version of rad 56 is 2 rad 14. Okay, so I'm going to get x equals 16 plus or minus 2 rad 14 all over 4. Okay, now this is where it gets kind of neat, kind of interesting. Now, we just went back to February. We're going to go back even further to September, October time, where we learned about distributing. There's a 4 down here. We can distribute it to every term up above, because that's just saying dividing by 4 is the same as multiplying by 1/4. So now I'm just distributing it to all the terms there. So I could write this as 16 over 4 plus or minus. I just treat it as one of those, a plus or a minus. It separates terms over 2, or sorry, plus or minus 2/4 times rad 14. Okay, I can simplify 16 over 4 is going to equal 4 plus or minus 2 over 4 is 1/2. All right, and I still have that rad 14 there. That rad 14 is just multiplying. You can kind of treat it like a variable. There's nothing we can do with that. We're not dividing it by 4 because it's inside of the radical. So this is actually an exact answer right here. This is an exact answer. Now it looks like there's just one solution, but really this plus and minus can break up into the two different solutions. So we can write it as one like that, or we can break it up into 4 plus 1/2 rad 14 and x equals 4 minus 1/2 rad 14. Okay, so this answer is completely fine for writing an exact answer. But this is just another way we could write it, an exact way. Now, I think that breaking it up is going to make it easier for us to approximate, because we're approximating two different things. We're approximating this and we're approximating this. So now to approximate it, we just want to put those values into our calculator. So we'll have 4 plus 1/2 times rad 14. And that's going to get us 5.87. Okay? The other possible solution is 4 minus 1. Oh, how did I get 1/4? That should have been 1/2. Still the same. The only difference is that plus or minus. Okay, so 4 minus 1/2 times rad 14. Make sure you know how to plug that into your calculator. And we would get that x is approximately 2.129. Well, this 9 rounds the 2 to a 3. So x is approximately 2.13. So these are the approximate solutions. Okay? So that's two different ways you can break this up. You can get an exact and you can get an approximate. And then I did want to also make sure you guys understood two different real ways you could write your exact answer, as a plus or minus, or you can just break it up into the two different 1 plus and 1 minus. Okay, in the next video, we'll go ahead and do the next word problem.